So you'll have the chance. You've had the chance to then convert using this other method. Sometimes I personally like those. I usually leave that little heart method diagram. It's in the back of your periodic table as well. I'll put it on a 3x5 card, and then I'll just put it next to it, and that'll just be a reminder of whether I multiply or divide by gram atomic mass, multiply or divide by 6.02 times 10 to the 23rd. Now, the process of finding how did these scientists find those formulas early on? Well, they used to do some reactions, like heat up a compound and burn off all the carbon, for instance, and they would say, oh, the compound lost 23% of its mass. And then they react it with something else and say, well, that's got to be the oxygen. And they would slowly react out every piece and figure out the percent composition of these compounds. Percent composition is nothing more than the mass of one atom that it takes up in the compound compared to the whole compound. All right, now, like I said, in the early days when they were still trying to figure these things out, they used to be able to figure out what the number of grams of each of the atoms were. And so how would that work? Well, if it's 300 grams of carbon and 800 grams of oxygen, I'm going to change this one, like I said. That's supposed to be an 8, and it'll be fixed in the notes that you download. So you'll get a new version of notes in today's worksheet. But I'm going to take the 300 grams compared to the total mass. 300 grams versus 1100 is the 27, or 0.27 is the fraction, but that's in percentages, that's 27%. Now, if I take 800 compared to the 1100, and even though this does say 400 in the old notes, it is 73.73 or 73% of the mass of this carbon-oxygen compound. So that's one way you can do this. If they're actually given in gram amounts, then you just tell me, well, it's, you could figure out the percentage of composition for each one. Now, you may get a problem, though, that looks more along the lines like this. They'll just ask you, hey, I'll give you a formula of a compound, and you tell me what the percent of each element's composition it is. So, for instance, in sodium carbonate's interesting because I'll just take the mass of each of these atoms. Sodium is 23, if you look on the periodic table. So 2 of those is 46. 1 carbon is 12, so that's now 58. 58 and 48, because each oxygen is 16 times 3 is 48. 48 and 58 is going to be 106 total mass for this compound of sodium carbonate. So, like we said, there's 2 sodiums. That's 46 parts of 106 is the percent composition of sodium in sodium carbonate. That's 43%. When I divide that out, it comes out to be 0.43. And 0.11 for the carbon, so 12 into the 106. And then the last one, oxygen, is the 48, because there's 3 oxygens times 16. 48 grams of that total 106 would have been from oxygen. So that's 45%. So you can do that for any compound. Now, as long as you have the formula, you can tell me what's the percent of water in this compound, or what's the percent of hydrogen in this compound. That helps us get to this last step, which is what scientists were really, when they were trying to figure out what stuff was made of, they were trying to come up with their formulas, and they would literally have gone through and figured out the percent composition for these. Now, I'm going to do this in reverse only because these numbers are conveniently right here. So if I were to say, what if I gave you the percent composition of some mysterious compound with sodium where it's 43% sodium, 11% carbon, and 45% oxygen? And you can do this, in any way you want. The compound, if it's given in percent, you can change it automatically right to grams. Other problems, you're going to get them, hey, I've got 16 grams of sodium and 12 grams of carbon and 4 grams of some other element. And that's great, because the first thing you're going to do is, hey, I want the formula for these, so write down the elements that are in here. In this case, I'm just transferring it here. What is the formula of a compound that has 43% sodium, 11% carbon, and 45% oxygen? I'll just write the 3 elements. And I'll use the percentages as grams, because I can take any, if it's telling me percent, why not choose an easy percent, 100? 43% of 100 is 43 grams. Okay, I'll write down the gram amounts as subscripts, because that's going to remind me, oh yeah, I'm trying to get these subscripts. The gram amount of carbon is 11 grams, okay, 45 grams of oxygen. Now, what I would do is, this tells me that's the first step. If I want to get the formula for some compound, write out the gram amounts of each of the elements I have. And if it's in percent, just change it to grams. Now, let's change those gram amounts here into moles. Now, you could do it like we did before, write out that fraction that tells you how to get from grams of some substance, and so you put grams of sodium on the bottom, and you put moles of sodium on the top. Okay, 1 mole is 23 grams, like that. But I do like, and I will continue to use, where I just do the conversion and say, hey, from grams to moles, I multiply by the 23, which is the gram atomic mass of, I'm going against the arrow, so let me, got to remember what I'm doing. Divide by the gram atomic mass, which is 23. Okay, I'm going to go against the arrow from grams down to moles. And so I'm going to divide 43 by 23, and that is a little less than 1, so that's about 2. So that comes out to be at 1.9, roughly. So now my formula is sodium, 1.9, divide 11 by 12, and that's 0.9-ish. Okay, it's a little more than 0.9, but I'm going to just call it 0.9, all right? So carbon's going to have a formula. These have now been changed into moles, 1.9 moles. Divide this by 12, and so this is going to become 0.9 moles. Okay, and oxygen is 16. So I'm going to divide this, and this is going to become 2.7 moles. I'm going to divide that out by 16. 45 divided by 16. It turns out to be about that, okay? Now, this is crazy because, yes, this is in moles, but it's not very simple numbers of moles. I want to get the ratio of these moles. So that's where this last step comes in. Divide by the smallest amount of these 3 mole amounts, and you should come out to be close to a nice whole number. Now, there are some times when you divide by that smallest one and you come out to a half number, and then I would round it. I mean, I would double it. If it's close to a half, then double all the numbers and gets rid of halves. But let's just divide these both all out. If I divide all these out by the smallest number, 0.9, 0.9, 0.9, okay. If I divide all those through, I'm going to get a formula where 1.9 divided by 9 is a little around 2. And I'm just going to go ahead, oopsie, sodium is right around 2. 0.9 divided by 0.9 is 1. So there's 1 carbon, and 0.9 into 2.7 becomes 3. Okay. So that's what these steps are determining. And you've got 4 problems that I want you to go ahead and work on in the back there, okay, that use that method.